Welcome to video 9.4b, apply the Pythagorean Theorem. All right, we got 4 examples here. First one's very straightforward. Solve for x. For the Pythagorean Theorem, I like to say leg squared plus leg squared equals hypotenuse squared. You're a leg, you're a leg, you're a hypotenuse. So 6 squared plus 8 squared equals x squared. 36 plus 64 equals x squared. 100 equals x squared. Take the square root of each side. I won't take the negative because I can't have a negative side length. So x equals 10. Okay, pretty straightforward. Example 2, find the perimeter of the rectangle. Okay, so I'm underlining a keyword there. So notice I've got a diagonal of the rectangle. So this is a right angle also. I'll concern myself with this right triangle. So again, leg squared plus leg squared equals hypotenuse squared. Leg, leg, hypotenuse. So x squared plus 5 squared equals 13 squared. X squared plus 25 equals 169. X squared equals 144. Again, I won't do plus or minus the square root because a side length cannot be negative. So x equals 12. Now, very often students stop there because they solve for x. They don't care about x, they want the perimeter. So we're a 12 here, we're a 12 here, we're a 5 there. So the perimeter is going to be 2 12s plus 2 5s. 24 plus 10 equals 34 units. Okay, example 3. Find the perimeter of a rhombus with diagonals 6 and 10. I'm a visual person. I'm going to draw a rhombus. All right, so like that, like that, like that, like that. Doesn't have to be exact. I'll draw in some diagonals. Okay, if you want, you can make the longer diagonal be the 10, the shorter one be the 6. Remember that a rhombus is a parallelogram and the diagonals bisect each other. So if this whole diagonal is 10, it's really 5 and 5. If this whole diagonal is 6, it's really 3 and 3. And also, for a rhombus, the diagonals are perpendicular. Ooh. We'll get a right triangle. What I'll do is I'll call one of the side lengths x. Once I solve for x to find the perimeter, I'll just multiply it by 4. All sides of a rhombus are congruent. All right, so again, for the Pythagorean Theorem, it's just important to identify the legs and the hypotenuse. So you're a leg, you're a leg, you're a hypotenuse. So I'll simply say 3 squared plus 5 squared equals x squared. 9 plus 25 equals x squared. X squared equals 34. Again, I will not take the negative square root. I can't have a negative side length. So x equals the square root of 34. That cannot be simplified. They don't care about x. They want the perimeter. So the perimeter would be 4 times the square root of 34. Okay, again, always remember to answer the gosh darn question. All right, example 4. John walked 3 miles north, then 2 miles east, then 4 miles north, then 13 miles east, then 1 mile north. Okay, a little zigzag. How far is he at the end of the journey compared to the start? Okay, well, I'm going to do it this way. So just so you guys are aware, that is north, that is west, that is east, that is south. So basically it's going up and to the right. All right, so I'll just do a quick little drawing here. So he went 3 miles that way, 2 miles that way, 4 miles that way, 13 miles that way, and 1 mile that way. And basically what we're going to know is the distance from the start to the end. Well, what I'm going to do is just draw a straight line from the start to the end. And what I'm going to do is construct a right triangle. And I want to find that distance x. All right, well, I know that this length here is the same as the eastern components, okay? So 2 miles and 13 miles east, that's really 15. And I know this is the northward components, a 3 and a 4 and a 1, that's going to be an 8. So the problem boils down to just finding the hypotenuse of a right triangle with legs of 8 and 15. It's that simple. All right, again, leg, hypotenuse. So I'll simply say 8 squared plus 15 squared equals x squared. 64 plus 225 equals x squared. Let's see here, that's going to be 289 equals x squared. Take the square root of each side. Again, x can't be negative. The square root of 289 is 17. So x equals 17. How far was he from the start? 17 miles. So I'll just answer that. 17 miles distance from the start. Again, always make sure you answer the question. So there you have it. 4 examples on applying the Pythagorean Theorem.